Section 3.3, Properties of Logarithms. So as we move further and further into working with logarithmic equations, we're kind of gathering more and more properties to help us solve those equations. One of them is the change of base formula. This was a way to calculate logarithms back before calculators when you had log tables. Everything was in terms of log base 10. So what you could do is if you had log base a of x, you could take it as base 10 and do log base 10 of x over log base 10 of a, because you had log tables that you could refer to, set up that ratio, and then calculate your answer. So log base 4 of 25, that would be the same as log base 10 of 25 divided by log base 10 of 4. And when you calculate that, you get about 2.322. All right? Now this isn't the most helpful formula anymore because we have calculators, but it's good to know history. So you can take a look at example B, check my notes, just make sure that you're plugging things into the calculator correctly. Now we know the logarithmic function with base A is the inverse of the exponential function with base A. So it kind of makes sense that some of the properties with exponents also apply to logarithms. So what these are kind of expansion and condensing formulas. What they do is they don't actually help us in solving anything. They help us in rewriting a problem, and the rewrite is then easier to solve. So some properties, the product property, quotient property, and power property. If you have log base A of a product, you can give each of those pieces in the product their own log base A, and then you're adding together. So log base A of U plus log base A of V. Also works with natural logarithms. And here's the nice thing about these properties, is they go both ways. So if you have a sum with like bases, you can condense them into a single logarithm. That equal sign works both ways. Quotient property, log base A of U over V. If you have that quotient, you can split it up so that each numerator denominator get their own log base A. And again, that works both ways. If you have two log base A terms being subtracted, you can condense those into a single log base A and a quotient. And lastly, log base A of U to the n. If you have a power inside your logarithm, that power can come out in front, become a coefficient. And of course, that goes both ways. Now what we're looking at today is we're not looking at solving anything, just at rewriting. So example A, write each logarithm in terms of ln2 and ln3. So we don't want to solve anything, we don't want a numeric answer, we just rewrite. Now 6 is the same as 2 times 3. So to rewrite using the product property of the ln of a product, I can split that up into ln of 2 plus ln of 3. Rewrite, not solve. Okay? Down here, expanding a log base 4 of all of this stuff. Now what's going to happen is all of this stuff is going to get its own log base 4. Now these are all being multiplied together. So we have log base 4 of 5 for that term right there. We have log base 4 of x to the third for that term right there. And we have log base 4 of y for that term right there. So each term inside that log base 4 gets its own log base 4 to call its own. The last thing we can do to expand is this power can come out in front as a coefficient. So log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So just getting practice, rewriting these using these properties, and remember whether they want you to expand or condense, take a whole bunch of logs and put them together, these properties do work both ways for that.